November 20, a sound wave a sound wave is detected by a microphone that is connected to a CRO. The trace on the screen of the CRO is shown. The time-based setting of the CRO is 2 into 10 power minus 5 second per centimeter. Determine the frequency of the sound wave. We should draw our x-axis. Determine the frequency of the sound wave. So how we find the frequency? We should find the time period. When we want to find the frequency, we should find the time period, and time period is then converted to frequency. Look at this screen. Will it be one cycle?
Yeah.
This is one cycle. And how many divisions are there? So we say 1, 2, 1, 2, 3, 4, 5. There are 6 divisions.
It will be 1.2 times 10 to the power minus 4. And then frequency is 8,000. So 8 times 10 to the power 3.
So we got the frequency, and this is a mixed question. The intensity of the sound wave is now doubled. The frequency is unchanged. Assume that the amplitude of the trace is proportional to the amplitude of the sound. Sketch the new trace shown on the screen. Intensity is doubled. But doubling the intensity, as we were discussing on that day, doubling the intensity does not double the amplitude. We have a concept of I1 upon I2 is equal to A1 upon A2 whole square. We can count the boxes for the amplitude, or we can give it any scale. So this is the initial amplitude. How much it is? Is it 1.2 centimeter, or what should I do? Because it's 1 centimeter. Yeah, 1.4 should I say?
It's 1.4, right?
Right.
So that will be 1.98.
So we have shown all the working.
Why did it become 10 centimeter?
Oh, sorry, 2 centimeter. So you have to keep the same frequency, but you have to increase the amplitude. So you have to draw a new trace. Look at the shape. The time base is now switch off. Describe the trace seen on the screen. Time base is the x-axis setup. So if you switch off the time base, describe the trace seen on the screen. It will be a straight line. Once you switch off the time base, the waves are no longer jumping. So can you tell me when time base is x-axis, time base is x-axis. So when you switch off x-axis,
Then it will just form a vertical line.
a beam of light of a single wavelength is incident normally on a diffraction grating as illustrated. Figure 5.2 does not show all of the emerging beams from the grating. The angle between the second order emerging beam and the central zero order beam is 16 degrees. What's the formula? N lambda N lambda is equal to d sine theta.
Will it be 4.7 times 10 to the power minus 7?
Can you please repeat the answer?
4.7 times 10 to the power minus 7.
Okay, thank you. It looks fine. And determine the highest order of emerging. Highest order, we need angle 90.
7.2 times 10 to the power 12.
Seven 7.2, but how it's coming because it's order. Can you please repeat 7.2?
Times 10 to the power 12. Let
No,
me see again. I think I'm doing something wrong.
it should be a count like 4, 5, 6. 7.2 is fine.
Because it will be 3.4 times 10 to the power minus 6 divided by 4.7, right? Times 10 to the power minus
But
7.
when power comes up, it will be positive.
Yeah, okay, 7.2. Just 7.2. I think I made a mistake before.
No, no. So it should be 7. Do we round always backwards for n?
If it's
N
less
is
than
always rounded backwards.
always?
Always. Because it's a count, like it's a real figure. Many people make a mistake. Suppose they get 7.9. So they would think it would be 8. No, it is just like O-level maths, real life questions, the common purchase questions. So suppose you have money enough to buy 7.9 apples. So will you get 8 apples? Answer would be no. I will get 7 apple and some change back. So this is called real rounding. Real rounding is always backward. June 14, 6. A hollow tube is used to investigate stationary waves. The tube is closed at one end. So should I say it's a closed pipe? There are two types of pipes, open pipe and closed pipe. A loudspeaker connected to a signal generator is placed near the open end of the tube as shown. Is it the story of node and antinode? Can you hear me? A stationary wave is formed in the tube. A representation of this is shown in the figure. 2 points P and Q in the stationary wave are labeled. Describe in terms of energy transfer the difference between a progressive and a stationary wave.
So a progressive wave transfer energy, but stationary waves don't.
Right, good. So should I say it is where is the node actually? What is node? And should I say it
Node
is
are where the 2 points meet, the 2 waves meet.
like this?
Yeah.
Now it's a 1 mark question only. But it's a theory. So June 14, 6. So let me try to The majority of candidates correctly identified the difference between progressive and stationary. A significant number of answers were incomplete with only a statement about the progressive wave being given. Now, this is a very important thing when you say, look at this. It means everyone is doing this part correct. So if you are making a mistake here, it's a big problem. And if you are not making a mistake, you are good and you are in a balanced state. So he says some students only refer to progressive. They didn't put a proper comparison, the fair comparison. So describe in terms of energy transfer. So a progressive wave transfers energy away from the source, while a stationary wave what should I say?
Won't you just say that progressive wave will transfer energy, but a stationary one won't?
No, basically, energy transfer occurs in a stationary also, but within the system. It is just like within keeps energy within the wave. So just like they hold the energy within the system. So progressive wave transfers energy away from the source, while a stationary wave keeps the energy within the system. Explain how the stationary wave is formed in the tube. Look at this marks, 3 marks. Now, this is A part 2, and this is a memory question because it has appeared many times in the paper. There were many answers that describe the general formation of stationary wave without reference to the situation in the question. This is worth reading, which I always see how they are feeling. Can you hopefully you can understand what thing he's pointing out. He says student is not required to write down a memory-based answer, which majority people do whenever a question come like this. They want people to engage the question. Now look at this. I tell my student that this is a sentence which should be framed and put it in every class. And people make a fun of me, said that you are wasting time. No one will look at this one, and that's fine. But I know, but this is something who is writing that. I always tell my student that, look, who is writing these sentences? The people who have checked the paper. It is just like the examiners, right? So if they are writing something and you say, oh no, I don't worry about it, and I will go to a teacher, or I will look at the solution, marking scheme. Marking scheme never tell these concepts. Very few candidates gain full credit for this point. Now, what is the meaning of this last sentence? It is a relative competition part. It means if you perform good here, you will be high rated. Examiner will be impressed. The previous part was done by everyone, and here everyone is not doing the right answer. So I have shown you very important things, and I have said that you should try to engage the question. Definitely, it's a 3-mark question. And when it is a 3-mark question, 3 ideas should be there. Let's see what the question says. A hollow tube is used to investigate especially where the tube is closed at one end and open at the other. A loudspeaker connected to a signal generator is placed near the open end of the tube. Now I have read the situation. Now, how should I answer this question? You have read the examiner report and you're not looking at the marking scheme presently. Marking scheme tells me actually that what are 3 marks for? 1, 1, 1. Marking scheme is actually that. So how should I write the answer? That he using the word the. It means he's talking about this one. So you will say that What should I say? That what's the main concept? A stationary wave is formed by the superposition of incident and reflected pulses. It is a phenomena of nodes and antinodes back to back, and it's a phenomena of superposition. This is the main idea. So you join all the points and you can make an answer. You can say that the loudspeaker emits a progressive wave which travels in the tube and reflects from the closed end. After reflection, the progressive wave superimposes with itself. This produces a stationary wave. State the direction of the oscillation of an air particle at point P. Uh, P is between node and antinode, stationary wave. Look at the oscillation. The particle will oscillate sideways within the tube because it has to move the wave forward. On figure 6.1, label with the letter N the nodes of the stationary wave. We already have done it. State the phase difference between P and Q on the stationary wave. Part number C. Q is above node. So do you remember node to anti-node, is it lambda by 4?
Oh, yes, sir.
Node to node lambda by 2. We know these features. We know that from our knowledge that node to node is lambda by 2. He's asking, by the way, P to Q. So what is the property? Points between two successive nodes are exactly in phase. Points between two successive nodes are exactly in phase. And when 2 points are in phase, what is the difference between them?
0.
0. But the reason always challenges the people. The speed of sound in the tube is 330. Calculate the wavelength of the sound wave. So we have the speed and we have the frequency 440.
So V divided by F will be 330 divided by 440. So that'll be 0.75.
0.
75.
Sorry,
75.
0.7. What is the length of the, sorry?
0.75.
Okay. Now this question is also famous. So how I can find L?
So node to node will be 1 by 2. So 1 by 2 plus 1 by 2 plus 1 by 4, which is 5 by 4, then times 0.75.
First I add them. How much it is?
5 by 4.
5 upon. How much is the answer?
0.94.
Sorry, point
94.